Okay, well, welcome everyone to our last live online meeting for the Foundations of Statistics course using R. And I hope that these online meetings have been helpful to you to practice and see how others solve problems in R, and to see alternatives to problem solving, and to give yourself a chance to meet some other people in the class. So thank you for your participation in the previous two sessions. I'm going to assume that you're here because you've attended the online meeting 1 and 2. And so this session is specifically intended to go over the lessons 5 and 6. And for your reference, in the materials tab, you'll find 2 data sets and 2 PDF files. So you can go ahead and download those if you haven't already, and we'll work with at least session 5's practice exercise today, possibly 6. We'll see how far we get. And also leave you with some exercises to complete at your own pace on your own. So feel free in this session, if there are any questions, feel free to ask them at any point. You can do that by using your mic, or you can do that through the text chat. Like always, I like to do what I call roll call, just to make sure that everyone is here and live, in addition to making sure that your mic works. So I've just unmuted everyone, and what I'm going to do is look at my list of folks that have registered for today and just call your name, and if you're here, just like give me a shout out. So and if your mic does not work for whatever reason, just type it in the chat. Okay. Right now, some people have their mics on, and so I just ask you to mute them on your own. So first off, Carlos.
Yes, I'm here. Carlos Bison here.
Okay. Hi, Carlos Bison. Thanks.
Hi.
Dimitri.
Hi, guys. I'm here. I'm a professor.
Hi. Welcome. Arun Murali.
Hi, Professor, here.
Great. Chinmaya. Chinmaya Joshi. I see that it looks like you're online, but maybe.
Hello.
Oh, good. Okay.
Hello. Yeah, hi. I am there. Yep.
Good. Welcome. All right. John Harris.
Present.
Great. Tanique.
Hi.
Hi.
Hi, good morning.
Libin Chen. All right, I don't see Libin here. We'll move on. Alexandro.
Hi, how are you?
Hi, good. Welcome. Pala.
Hi, yes, I'm here.
Perfect. Albert. Albert here. Albert Campillo. I see that you're here. Don't hear you. Okay, see you in the text chat. Thank you. Ajay. Are you here? I don't see you here. Okay. Next we have Carlos Arias.
Hello.
Hi.
Here.
Annabelle. Are you here? No. Okay. Barath.
Yes, I am here.
Great. Welcome. Cindy.
I'm here.
Great. Welcome. James.
Hey, I'm here.
Okay. Yanani. Yanani Noipan. I see that you're here. Just want to make sure that you're present. All right, we'll come back to you. Next, Patrick Smith.
I'm here. Good morning.
Hey, good morning. Heidi, I saw that you're here.
I'm here.
Great, welcome. And finally, Mark.
Mark here.
Great, all right. Thank you all. So just in case you're not aware, I do the attendance just to make sure that you're kind of present and things are working. But I actually know if somebody comes in late, or if you came in late for another session, I actually get an auto report generated for me. So if you're here and it will tell me like how long you've been online for, how long you're idle for, level of participation, things like that. So I know all of that already, but I just like to hear from you and just make sure that you're really present and make sure your technology works. Great. So you can participate at the level that we need you to. So this is your last session. So in the online gradebook after today, you will, for the live online meetings, you'll receive, if you've attended all of them, you'll receive a grade of 3. If you've missed one for whatever reason, just like send me a note, let me know. There's a way to make it up and I'll tell you how to. But I'd rather just do that kind of privately. So at this point, we're just going to move on to our agenda for today. And our agenda is pretty straightforward. I want you to be working on our session 5 exercise. I'm going to give you some time to work on that on your own. And we're going to slow things down a little bit to make sure that you're learning the things that I need you to be learning. And I want to make sure that you're comfortable working in our studio and ready for class when we meet in mid-May. So excited for that. Our other classes are going well, and you're finding this one particularly rewarding. I'm going to navigate to my R Studio. So you should see that on your screen right now, and you'll see like a bunch of stuff that I'm working on. And so one of the things that I'm working on is I'm working on a new book. It's called Becoming Visual, and it's all on data visualization. And when because I'm working on a new book and I'm doing a lot of stuff in R Studio, what I've done is I've created a project in R Studio. And this is something that I would encourage you to think about doing, because you'll probably be working on lots of different projects or lots of different types of activities in R or R Studio, and having them organized as projects could be really useful for you. So you'll notice this little tab over here where it says Becoming Visuals. That's the name of my project, and it shows me where the path for that. And I also have some other projects that are here. One is called Practice Exercises, and I can toggle between the two projects very nicely. And what it does is it keeps my working directories set for each of the projects. If I've created variables in those environments, it keeps my R history and my R data, which is really nice. And so I'd encourage you to create a project. And it's pretty straightforward on how to do it. So in this little tab here, you can just simply say New Project. And if you're working on something right now, it will ask you to save what you're working on. And then you can decide if you want to create a project as part of an existing directory structure or a new directory. So that's helpful. So you can start a project in a brand new directory. And then you can follow along with whether you want to create actually your own package. So one of the things that we've talked about in our last online meeting is actually packages and working with packages other people have created, but we can create our own. And we can also create a project, which a project will contain all of our data files, all of our .r scripts, maybe our markdown files, and any other file types that you're using. The other type is a Shiny web application. And I like to show this because we'll be creating our first Shiny application. Well, at least if you haven't created one yet. For those of you who haven't created one, by May, it will be your first Shiny web application. And so we'll create a very cool web app to show the possibilities available with R and how easy it is to kind of create web-based content that can be interactive, anything from graphs to applications. So I work with a lot of capstone teams. So you probably heard a little bit about the capstone project as part of the program. Let me know if you haven't. And so part of the capstone project is a year-long project that you'll be working on with the team, and you have the opportunity to select advisors. I generally advise 1 to 2 projects per year, and one of my teams is creating an app in Shiny to predict areas of gentrification in New York City to help inform real estate investors of various sorts, novice investors, seasoned veteran investors, and also people looking to get comparison data about different pockets in New York City that might be gentrifying. That could be an interesting investment opportunity for properties that are, less than $500,000. That's kind of some of their parameters. And so they're creating an app actually to do that. And it's pretty exciting. So the stuff that you're learning here in R, and I know that we started kind of like R as a calculator, in session 1, and now once we get into class, we'll be doing some things that are much more sophisticated and that will provide the foundation for, maybe even things that you might be doing in your capstone. So it's pretty exciting. You will all shine with a Shiny application in May, Jemaya, yes. And Pala, yes, scripts are associated with projects as well. So to answer your question. But just to kind of show you where things are going here. So we start up really slow because I want to make sure everybody has a good foundation, but there's so much that you're going to be able to do with R, and knowing that this is, there's many other languages that you'll probably be learning as part of this program, like specifically Python, if you don't know it already. But there are some nice advantages of using RStudio and to create apps and other things that are great for prototyping for capstone projects and things like that. Okay, so look into it. Hopefully that will be like motivating. You might look into it after this session, and there's great examples of Shiny apps out there. Okay, so one other thing that I wanted to just go over was about this project. So you can pick your project type. You're gonna pick an empty project, and so you pick an empty project. You give it a you find the directory name, give it a name. So it might be like, statistics course or something like that. And then you browse your repository subdirectory, and you could also link to a Git repository if you have a Git or a GitHub, and this will allow you to have some version control as well. So this is good if you're collaborating with, like, say, team members, for instance. So I'm not going to create a new project, but I encourage you to go ahead and do that now. I'm going to cancel out of here because I already have my project. And so this is my world for the book that I'm working on. I have, I have a script up. I'm working on creating some visualizations. And now I'm no longer working on my book. I'm teaching a class. So I'm going to go to my other project called Practice Exercises. And you see that I get, it says that I'm switching projects, and I can save my workspace image. So that means everything I've been working on is going to be saved. So the next time I go back to my Becoming Visual project, I'll get my script come up here. I'll have my data that's already imported, and I'll be able to work with that data. We'll probably, in the face-to-face meeting, we'll actually probably work with some of the data that I'm using as part of my book. So I'm using some bike sharing data, which is pretty fun. I'm going to be using some data from Epicurious as well. I don't know if people have heard of the Epicurious website, but they have a lot of recipe reviews. So we'll be looking at reviews, we'll be looking at bike sharing, and I even have some other pretty interesting data that we can look at from companies that allow us to use the data for academic purposes. So we're working with really small data sets right now, but it's not always going to be that way. So that's also something to keep in mind. Okay, so I'm going to get out of here. And now I am in session 5. So what happened is I switched projects. You see it says practice exercise in progress. That's the name of my project. Not that exciting. But then I have my script that I had open from before, and I imported a data set called movies, and that's already available for me to use. So it's nice that your data is your R. It's called the R data is saved at startup, and that R data file will be stored in the working directory that you've designated for your project. And you always will have the option to update that file on exit and save that history. Okay. So now I'd like you to take a look at the session 5 PDF file. And we're going to be working with a new data set here called movies 2014.csv. I'm just going to show you that just so you can take a look at that. There's different rankings of movies, release date, genre, gross, and ticket gross sales, and then tickets sold. And you'll see when R imports this data, there's like some things that it does that's pretty unique. So anytime there's a space, it puts a dot in the place of a space. And anytime there is a number, R always puts an X in front of that number. Okay, unless you use double quotes to rename that column. With using double quotes around a number, then it will include the quotes as part of the column name, which can be confusing and hard later on when you're trying to reference that variable. But that's a way to kind of get around that. Or you just rename your columns, your column names. And so we talked about that in the last live on meeting about renaming columns. So you can go ahead and do that if you want to fix up your data. We also talked about writing out your data to a new file. So you can update that CSV file or create a new CSV file with the new column names, things like that. So as part of our exercise, I'm going to ask you to import that data set, look at the data, look at the column names, just understand it. And then we're gonna move on to working on creating scatter plots. And because this part of this lesson that we're covering has to do with some basic data visualizations that you can create. Now, these are like very, very simple ones. And you have a whole course that I'm teaching in the future in October, I believe, in Shanghai, on data visualization. So we will have a lot of time to work on those, and we'll do them in R and Tableau and some other programs. But right now it's just to kind of get a sense of like how to work with some of the data visualization functions available as part of some of the packages like ggplot 2 and our basic graphics package. And we'll show some correlations visually. We'll create some scatter plots with lines, create some box plots, histograms, and other types of plots. So I thought we would just give you a moment to work on questions 1 and 2. So first, I'd like you to kind of import your data, the movies 2014 at CSV, and then work on creating the scatter plots. So that's questions 2A, B, C, and D. And when you've done that, why don't you share your code for questions 2A, B, C, and D with us in the text chat. So I have 12:20 Eastern Standard Time. So why don't I give you like a solid 5 minutes to work on this until 12:20. Oh, it's 12:21, 12:26. And I'll wait for some feedback in the text chat. So I'm just going to mute myself and then let you work on questions 1 and 2 from session 5. So if you're just joining now, we're working on session 5, and we're working on questions 1 and 2. Okay, this looks good. Heidi, I like that you're adding your X and Y labels and some titles. Great. Okay, see Dimitri's using the car package for his scatter plot. Nice. James, thank you. Alexandra, Carlos. All right, so it looks like most people are getting the hang of this. So let's go over some of this. So quite simply, we've read in our data, and we're taking a look at our obviously our column names. We might want to rename them, or if not, we look at the types of variables that we have. A lot of them are factor variables. We look at the dimensions of our data frame. And then you'll notice that we do a very simple plot. And this doesn't tell us much and looks pretty rudimentary, as you can see, right? So we're using the plot function, which is very, very rudimentary. And this comes from the graphics package. And so we're going to start using much more sophisticated visualization tools. But this just gets us our basic X and Y plot, like a simple scatter plot. You notice I'm getting, just my scales are very, unreadable. And even you'll notice that the labels for the X and Y axes are based on the data frame and variable name, which is very, very messy. So we can clean that up a little bit first by dividing our gross sales by 1,000, just to adjust that a little bit. So we can see what's happening there, but our labels are still looking pretty messy. And so we need to scale again by 1,000,000. And then I can plot it again, looking a little cleaner this time. So that's one thing to think about, is how what your scale looks like. And you'll notice in RStudio that my graph looks very stretched out. If I click on zoom, it looks a lot better. And so that's the plot that you can then export or use for something else. So that's just something to consider. And I'm just looking at people's answers here. Thank you. Carlos has a nice, elegant solution. I like what James has. He's adding, main. So we're going to go ahead and add a little bit more information here, such as main is a parameter that will allow us to put a title for our chart, an X lab, which is a label for our x-axis. We can write that in English instead of it saying movie $tickets sold millions. And we can add a Y lab or a Y label for gross in terms of dollars, and decide if we want a frame or not. So you can go ahead and add those to your final chart if you like, just like I did. So you notice now I have, and I took this from James, right? That was like his recommendation. So thank you for that. Because now we have our charts looking a little bit more readable. And we can zoom in and see it there. Now here it's still not going to be perfect in terms of a lot of the design principles that we'll look at, but we certainly can see some improvement by changing the scale, okay, and also adding those labels. I'm looking at You can also, Chimaya, yes, you can use the attach function. So if you did not want to reference the name of the data frame, you could. I'm going to assume everybody's like getting to this point. Please take the moment to modify your code so you are adding in the X lab and Y lab and the main parameters of the plot. Okay. And there are many different parameters that you can add. I'm scrolling through my frame now so you can just take a look. But if you just go to $plot, we'll get the documentation on generic X and Y plotting and the different types of plots that we can show. And these different parameters like main, an overall title for the plot. Somebody add a subtitle. You can also add a subtitle. Your X lab, which is your title for your X axis, and Y lab. Okay. And there's even some nice examples that you can try. There's some data sets that are already preloaded in your version of R. One is called cars, and you can simply use this as an example too. And you could even add things like colors and point size, and it gets very, very specific, obviously, because there are going to be things that we do want to modify. So let's go back to session 5, and let's move on and do the next 2 questions. So I think number 3 we can answer. Is there a correlation between tickets sold and sales? Yes. And we expect that. Why? There's a perfect one, says Dimitri. Okay, and then if you could go ahead and do question 4. So by just going ahead and adding a regression line. And then going ahead and making sure that you add the labels as well. Like I have here. And if you're just joining now, I see that somebody just popped in. We are working on session 5, and we're working on creating some simple graphs in R. And we are now on question 4. And some folks are using actually the car library, which is great, and then using the Scatterplot function. So I encourage you to do that as well. And And I'll work on my example as well. My variable names are different than yours. So as you can see, the car package will generate a graph that might look a little bit better to you. It's subject to interpretation. You also get this nice box plot on the side. However, and you get like a little bit of color here with our regression line, but you also see grid lines. And as you get more sophisticated with data visualization, you'll learn that grid lines are not always like the most helpful thing. Sometimes they detract from what actually looking at the data. And in this case, grid lines really don't help us all that much here. But the rendering does look a lot better than our previous just using the plot package. It is more sophisticated. So, I mean, I encourage you to try out using the car package. And to learn more about it, you can go !car at the command prompt. Oops. Car. And you can learn more about that. And there's a URL there for learning about the car package. And I think I mentioned that in the lesson, the graphics lesson as well. Okay, I'm just checking for your work. Good, I'm glad some people are using the Scatterplot. So again, we went through and we used the basic plot function from the graphics package to show our Scatterplot. I'll just run this line just to recap, and we get something that looks like this, okay, with our regression line. And then based on what you guys have been doing, some people are using the companion to applied regression package called car. So if you want to do that, you can then invoke a function called Scatterplot and get a Scatterplot that looks maybe a little bit arguably visually more appealing. Okay. Now there are other questions that I ask you, but I want to introduce you to something that also has a very nice display, which is a package called ggviz. Has anybody used ggviz? This is the word I'm saying. Yeah, so you can also try that out using the ggviz package. It's a little bit, you have to make sure that you have it installed, so it may take you a little time to do that. You'll see in my version of R here, I don't have it installed, but it's something that you can use. We'll be using something called ggplot 2 at some point. And if you wanted to install ggviz, you go to install and then you just find it and say ggviz. And it will come up and you can install it. And it will take hardly any time at all. And then if you wanted to actually create a scatter plot in ggviz, you could do something like this. And you can copy my code if you like. And you notice that I'm using a variable for my x-axis, not dividing it by 1,000,000. And that was just, I didn't go over that explicitly, but it's great to create variables rather than to kind of like perform the calculation like every single time that you want to use that variable. John, that's a good question. Is ggviz a follow-up to ggplot 2? It allows for interactive, and I would say slightly interactive, not interactive in the truest sense, but interactive in animated visualizations. So it has some aspects of Shiny, and it has some aspects of ggplot in it. And since I'm just typing this on the fly, I am sure I have a typo, but it looks more complicated than it is, but you're just basically passing in X and Y, and you're defining it as a point chart, which is a scatter plot. And so if I don't have any typos, right, so you can certainly try this on your own. But as I'm showing here, you get a chart that looks a lot nicer. I still have to go ahead and change my labels and all of that. But this is really the basics. And you could just see that the resolution, you get the same error. Well, you're getting the same error because you didn't require ggviz like I did. That's probably why you got the same error. So, and you can see that there's not much clarity when points overlap over each other either. But I mean, we see a clear relationship here, obviously. But just the resolution is a lot better in terms of the graphs that you can produce. And here you can also download your vector graphic as well, which is nice. And then you can go ahead and save that somewhere and then use it somewhere as well. If you wanted to use it in a report or something. And you see as my image gets smaller, because it's a vector graphic, the resolution doesn't change. I mean, it does get smushed at some point. Things will be a little bit unreadable, but still it keeps the resolution as it grows bigger and smaller, and that's a nice attribute of vector graphics. Good. So again, this is something that was not specifically in the exercise, but I like to show there's many different ways that you can create a scatter plot, and many different packages that will allow you to create one. And we started with the basic one that was just using the plot function from the graphics package. And then we moved on to using the Scatterplot function from the car package. And then we finally went to the using the ggviz layer points function, which you can see at the end really does render a nice visual. What I like to do after getting that visual is I might go ahead in Photoshop or Illustrator and actually edit my text of my visualization, because it is a lot of work to go ahead and, code in all the X labels, the Y labels, the title exactly where you want it. Maybe you don't like how it centers the title. You want it to be right aligned instead. Maybe you don't want all the grid lines. And so it's a real balance with visualizations, how much you want to code to output to the perfect visualization versus how much you want to edit later. So that's just a consideration. So I'm going to go back and look at our exercise. And go over one other way that we can create really simple visualizations, but using another package that some folks mentioned, which is ggplot 2. And so you can simply say require ggplot 2, and that will be a package that we can use to use a geom point method, it's called. And it's pretty straightforward when you're creating a ggplot. You call ggplot, and then you can, and if anybody has this done already, feel free to type your code in, and then you can pass in you can simply pass in your data frame. So in this case, it would be movies. And then we might have some aesthetics, which we use as AES, aesthetic mappings. You can see on my screen what that stands for. Let me bring that up again. I describe how variables in the data are mapped to visual properties. So that's everything that we're doing in data visualization is that. Okay, so what is it about our aesthetics that we want to change? I will show you. So first we want to pass in our variables again, tickets, sold millions. You notice as I start typing, my variable name comes up, which is handy. And then we can add our geom point, it's called. See all the different types of plots I can create. As I scroll down here, I want to choose the point. Somebody's asking about jitter. You can create your jitter plot here. So let's do this. And since I'm typing, it's possible I have a typo. Let's see. I'm going to require ggplot. And what did I do wrong? I didn't say ggplot 2. So ggplot 2. And then I'm going to run my, again, I don't have my labels or anything here, but I just want to show you kind of out of the box ggplot what type of visualization you get. Okay, so you can see ggviz as a nice iteration on this. This is okay. I can go back in my plots and you can see the differences between. So this is the one that's created in the graphics package. This is one that's created using car. This one was created using ggplot. Okay. Oh, somebody asked me why didn't I use here? I just I didn't actually put movies, dollar sign, tickets sold in millions, and here I did I could simply remove this. I don't need to mention the data frame here because I passed it in over here. So one other thing that is, I think, kind of fun. Has anybody heard of Edward Tufte? Okay, so Edward Tufte is considered the grandfather of information graphics. He has like at least 4 books out on information design and graphic design for data visualizations. And his work is very influential in the area of data visualization. And there's actually a package which, could be updated a little more frequently, but a package in R called GG Themes. And GG Themes actually has a theme that we can apply to our visualizations called Theme Tufte. And that means we can take what we have, like in GG Plot here, and make it look as if Edward Tufte got his hands on it and modified some of what we call the non-data elements to simplify it and to allow for the data to speak for itself. We also have other themes that we can apply to our graphics, like we can make our graphics look as though they were published in The Economist. And they'll have like this kind of bluish background, or the Wall Street Journal, they'll have this like pinkish background. So there's some other customizations that we can use. And I don't know if you'd be interested in me showing you that, how to apply that. So that's just kind of a question. We can spend a little time on that. Okay, and so these are GG themes are things that we can apply to GG Plot, not necessarily GG Viz. So just things to think about. So what do we need to do? Well, guess what? We need another package. So, and you'll notice that you probably don't have one called GG Themes. So you're going to have to go ahead and install another package, and it's called GG Themes. Okay, and you can go ahead and install. Normally I don't do things live like this so much because there's like a risk of failure, especially when you're teaching, but I'm having luck so far. So it's a pretty small package, so it loaded. And then in your code here, you're going to want to say something like require GG theme, so then you can invoke that. Okay. Now, if I wanted to take my code that I wrote before, my GG Plot code, down here, I'm on line 74, and then scroll all the way over to the end, after I do this append, I'm appending the type of, so I pass in my parameters. Very simple. GG Plot, I pass in my parameter. Like the first thing is X. X is my data. So I pass in movies, and then I define the aesthetics, which in this case is like really simple stuff, just are my X and Y, right? Tickets sold millions and then gross millions. And then I append, quite simply, the type of chart I want, which I showed you that before. And then I'm going to do one more using the plus operator. And I'm going to say theme underscore and check out what I get. I get black and white, calculator, classic, dark, economist. And then you can scroll down and see all 538 for those of you that are 538 fans. I can make my graphs look like they are produced in Google Docs, like they were produced in Excel, God forbid. I'm very anti-Excel out of the box graphs for obvious reasons. But you can look at many different types of themes, like the Wall Street Journal, for instance, and one called Tufte. So we can pick Tufte. You can have fun with this and run. and it could say can't find theme Tufty, and because I didn't go ahead and execute this line, now it loads my package. Now I have to run, and it should find theme Tufty. And you'll see here on the right-hand side, again, I don't have my labels done yet. I got to work on that. But you'll see that it's very minimalistic, okay? So we get rid of grid lines. There are a few tick marks, but the font has been changed to kind of a more readable font for paper, which is what his design principles are really for. If you don't like that, you can go ahead and choose another one. Not all of them work all the time. I've had some problems. Say if we want to choose The Economist. Again, I haven't tested this. But like I said, it comes with that blue background, and I can have a theme that looks like my chart came from The Economist. So this is available to you for Jitter Plot. And it will save you some time in terms of just like making your charts look good. It's still your job to make sure that you have the scaling correct and that you have your labels correct. So I'm not going to go over how to change labels and everything in Jitter Plot. You can take the time to do that. John, I'm glad this will save you a ton of time. And at this, you can really experiment with this. And if you if you spend the time to actually write all the code to design how you like your charts to look, then you can save that and always reuse that as well. So that's another thing to think about. That's why we use R scripts. So then you can save some of those aesthetic properties that you take the time to put together. To learn more about Jitter Plot, you can go Jitter Plot 2 and learn more about it. There's lots of great links here. So this is a good place to start. And so our friend Hadley Wickham maintains this. So I think I've mentioned him a few times before. And he's just done so much work in this area and just really a leader. So we need a theme named after me, Professor. Oh, thanks, Heidi. Okay, if you guys create it. And you can create your own package, which is like Sisolsky themes or something. Cool. So it's 101. So what I like you to do now is take some time to work on the other types of plots. And you should have some inspiration to maybe use Jitter Plot 2 to create some of these. Now that you know, let me just scroll up here. I go to line 74, that I can just change this, and this changes the type of plot that I might be creating. So if I use if I don't use point, maybe I use bar, for instance, that will give me a different type of visualization. Or you can use some other functions that we talked about in the lesson, like histogram, like HIST, etc. So what I'd like you to do is work on question 5, letters A through I. I don't know why there's no H, but I guess it got deleted. But letters and create some histograms and box plots and share with the class like how you approach those. So it's 103. So let's take at least until like I'll check in at 110 and see how folks are doing, and then we can go from there. Okay, just checking in to see how everybody's doing. I think one or two people have shared their work. So, thank you for sharing. Okay, so thank you. Oh, good. So somebody used the Jitter Plot histogram. Density plot. Good. Good. Using classic themes. So everybody should scroll up and take a look at your classmates' code. Really interesting. Uh-oh, I see some typos. Okay, looking. So I'll go over some super simple ways of solving this, and then what I would do is encourage you to go ahead and if you haven't, to use your ggplot 2 package to create some of these. Good. So if we're going to see a box plot of gross sales, we can simply use the box plot function. Okay, and looking where that comes from, you go to box plot, and you'll see that that comes from the graphics package, just like the plot. Okay, again, so you know this is going to probably not look that great. And here we know that with a box plot, what does a box plot show us? So we know a scatter plot shows us the relationship between two variables, possibly might show us correlation, not necessarily causation. And what does a box plot show us? Okay, so let's look at one. Thank you to Maya and Carlos for your responses. So again, looking at this, what am I able to take away from this particular graph? Right, I can see maybe an outlier. And what does this dark line mean here that I'm pointing to? Some people say the mean, some say the median. Which one is it? They're different. They're way different, right? So it's the median. And you could always take a look at the median by using the median function to know what that is. But yes, the dark line represents the median, the middle value, not the mean. And if I want to do a simple box plot where it's going to be a horizontal box plot instead of a vertical box plot, I could set my parameter horizontal to true. Okay, do that. Zoom in. And sometimes that's easier to see. I always find it's better to be able to read your axis looking horizontally with something like this, but it helps you align the line a lot better, the median line. In any case, good. And then you could also try to actually get the median, right? And then compare that to the mean. And see what the difference is. So clearly we've just proved that the line represents the median. So that's 27.6, where the mean is much closer to is 44.6. Okay. Simple stuff, but important that we know how to interpret the graphs that we create, right? So let's continue on. So next we'll do a histogram for types of films. And so we get an error, right, if we try to do a histogram on the types of film by genre, just running the histogram function, right? So if I run that, you'll see X must be numeric. Why? Well, let's just take a look at movies in our genre column. Okay, well, that's not useful to be able to graph something by frequency if it's not a numeric variable. Okay, so what we need to do is go ahead and cast it as numeric and to do a histogram of that variable. So my point was that we're going to have to cast. I went to the wrong line of code. My genre as a numeric, and I'm able to actually. I don't know what those numbers mean yet, but I'm able to actually visualize. I can also do a table, Dimitri. That's very good. Patrick, I have, I think I have, I'm not sure of your question, but maybe you can explain it. So if I do like str movies, and if you just take a look at my screen here, genre is a factor with 8 levels, and you can see what those 8 levels are. Well, you could see a few of them, action and adventure, and those are each assigned a value. And that's why I'm able to graph it as a histogram, because there are values associated with that. I could also create a table as well. Well, and I'm doing a histogram, not necessarily a bar chart. If I was doing a bar chart, you should see 8 bars with that. So let's see if we could illustrate that. this is not useful. Sorry about that. So let's go back to our histogram because we're showing frequencies here, not necessarily quantities. Okay, let's get rid of. The bar plot's going to want us to do this as a table. Okay, so we could also do a histogram of the movies gross, and you're going to see that it gives us just 5 bins. We can specify the number of bins by including those as breaks. Okay, so I can include that there. We get a little bit more clarity with our histogram and our frequency distribution. And you could also try doing your histogram for tickets sold if you wanted to. And again, I'm not doing that. I did not change my scaling there. But you could also include many more breaks. And obviously, if you use the tickets sold million, it'll be a lot clearer. If you wanted to take another step and put the frequency counts on top of the bars, we could put labels equal to true and run that. Again, very primitive stuff. And you can see that we can't even see all the data when we use kind of these primitive chart types, and we have a lot less control. So I see a conversation like happening around all of this as well, and it's because we are using some primitive graphics functions right now. So if we go ahead and create a bar plot, and we do that with a table instead. So now we're measuring what? Well, we're measuring proportions of a whole, as you can tell by you could say the percentage of action movies and other types. So there's a lot of ways that we can think about working through some of these exercises. There is one more thing I do want to talk about with this. If we go back to quickly, we could say table, movies, genre. We could run that, and we can actually see how many the counts for each genre by movie. And then what you could do is do a bar plot of that. using a prop table and passing in our table that we just created. Again, a lot of work is needed. Not every bar is labeled. And so how would we go ahead and label that? Well, we actually have to take some time to code that, to change the font size of our text. It can get pretty complicated just in terms of the amount of code that we need to use. So we can change the size of our font. And we can also change the names, create a vector of the names that we want to use for each of the bars. So we can type in things like action, and you can try doing this. Or just bring it into like Adobe Illustrator and then just type it out yourself if you know what the actual bars represent. And since I'm kind of doing this live, there's probably a chance I'm going to make a mistake or a typo, but I do kind of want to illustrate this to you. I should have 8 there. So if I zoom in, you can see that I'm still missing some. They don't seem to be fitting on my visualization, but that you have the ability to, when I zoom in fully, every bar will then be labeled. Oh, good. There's some other, using ggplot, we're going to have a lot better luck, right? Okay, so at this point, it's 1:30. So we spent a lot of time working on visualizations today. There is another exercise for you to work on. I know that I've been asked a few times for some extra exercises, and so this is an extra one. It's focused on session 6 on messy data. And so you can start working with the data set here and working out some of the problems that I posed to you. And I'll stick around if you have more questions for me. I really appreciate everybody's sharing and examples today. I thought this was a really, I always like this last session where we kind of can start doing things and like seeing some results of some of our manipulations of our data, whether it's just creating visualizations or tables, things like that. Please let me know if there are questions, if there are things that you'd like me to cover in class that you're curious about or we're hoping that we would talk about today or another time. Please don't hesitate. Let me know. We'll try to fit it in. This is your class, so let's make it your class. So I want to thank you for your time today. And I'll stick around, but what I'll just do right now is just stop the recording.